Hey, it's Ed the Third, and for this project we are going to be doing something basic. Compared to the first project video, this is easier, at least I think it's easy anyways. I will be going into depth as I show you how to code a bubble sorting algorithm and more importantly, the logic and thinking it takes to create such an algorithm. Because the objective of this sorting algorithm isn't to sort a list. In Python you really have a method and a function to do that. Is to get you thinking critically and develop the ability to break down a problem into parts and then code the solution. So this won't be like most videos on the topic. Of course, I will be showing you the working code and how to get there and everything. But I expect you to be working alongside this video, even if it's just manually moving numbers or writing pseudocode on a piece of paper. You don't have to code next to this. The whole point of using such a bad algorithm is just to get you to think about the next steps, how to break down the problem, how to write the solution in this specific language. Now, I neatly sorted this video into chapters. You saw them in the beginning and they should be in the description with a timestamp. Watch an entire section first, and then if you're confused, I'd say go back and rewatch that bit. I will be doing other algorithms later on and they will get more complex, but this video will just be bubble sort. So enough waffling, let's actually get on. So I'm going to just quickly work through an example here. Let's say you have this list that's unordered and you want to order it. The bubble sort would work by going to the first element, which is 4, checking if it is greater than or less than 2. It's greater than 2, so you would swap it. Now, is 4 greater than or smaller than 9? It's smaller than, so you leave it. Then you go to 9. Is it greater than or smaller than 1? It's greater than, so you swap it. Then 9 with 5, and you swap it again. Same with 0, you swap it. Same with 6, you swap it. You are now at the end of the list. That is one pass. Now 9 is in the correct position. 9 won't change because it's now bubbled up to the top. So you would go again. And just for simplicity's sake, I'm just going to show you with manually. So you again go to the beginning. Is 2 greater than or smaller than 4? It's more than, that's fine. You go to 4. Is it greater than or smaller than 1? It's greater than, so you would swap it. Is 4 greater than or smaller than 5? It's smaller than, so you go to 5. Is 5, you get the idea. It's greater than, so you will swap it. Again, it's smaller than, so you just go to 6. Is 6 smaller than 9? Well, I mean, technically this is the end of the list, but no, it's smaller than, so you leave it. So now you have 2 sorted elements here. Go back to the beginning. Oh, it's bigger than, so you will swap it. Smaller than, now you compare again. It's bigger than. And right here, it is smaller than, so you leave it. These two are already sorted, so you know this one's all sorted as well. And now you have 3 elements that are sorted. Again, the beginning. Is it smaller than or bigger than? 1 is smaller than 2, obviously. 2 is obviously bigger than 0, so you will just swap them around. And 2 is smaller than 4, and so on, and now you have all of these elements sorted in this place. Again, you go to the beginning. 1 is bigger than 0, so you swap it. Done. That's that one pass done. And now, well, now the list is sorted. You don't need to compare it again, because if all of these are sorted, of course this is going to be in the right place. And every time I went back to the beginning, that would be another pass. So hopefully you now understand it in theory, but in practice it's something else. So to tackle this problem, we need to first create a function that accepts a list. Here I call the list ARR, which is short for array. All we're doing is finding the length of the list and sorting it as the variable n. This ensures that we can pass through the list multiple times. Now a while loop can be used, but the maximum amount of passes we need is always going to be n-1. As each pass means that at least one element is in order. Specifically, it's the largest element. You know the largest element will always be in the correct position, which is the last position after each pass. So that's why it's n-1. Just think about this before I explain why. Maybe manually work through an example. So if there was a list 5 long, after 4 passes, the last 4 would be in the correct order. So therefore, the first number has to be in this correct place because there literally is no other option. And that's why the for loop is up until n-1. So now is the primary logic of the algorithm. How do you compare the first element to the next and then repeat it? You probably would have guessed the for loop, and within that for loop, an if statement. If the first element of a list, remember that the index will be 0. If the first element of a list is greater than the next element, you'll swap the positions. But how do we write that? How do we know when to stop? How do we move on to the next pass? If it helps, think about what things we already have. So we start at index 0. That's because indexes in Python start at 0. Okay, easy, understand it. We got n, which is the length of the list. For simplicity, let's say it's 5 long. We also got that integer value from the outer loop. That is how many passes we did. And we know after each pass, the last element in the list is in its correct position. So therefore, we subtract I, because for the I pass, there's already I elements in the correct places at the end of the list. So you don't need to check those. You may have noticed we're missing something here. When you swap a position, well, how do you swap a position? You know where you're currently at, and you know what you want next. Great. What if you are at the end? You don't want to compare those, because it will cause an error. That's where the -1 comes in. It means it will always be 1 behind. So, let's say, with example, it's 5. When you swap a position, you would go to the next element, so it would be your current position plus 1. But if you are at the end of the list, there is no +1, there's nothing there. So what you do when you do -1 is you prevent that from happening. So you do, if the list is 5 long, it'll be 0 to 3, because remember it starts at 0, well, okay. So the beginning is 0, the ending is 4, but you do -1 because there is no fifth one, there's nothing there. So you limit it to whatever the length of the list is, -1, so it doesn't do that and cause an error. And by the time you get to the end, it would have already been sorted, because after each pass, it's always sorted at least one element. So hopefully that makes sense. I will quickly go through a very quick example. So working through an example, hopefully your example has a similar outcome. Again, please work along with me. If we had the list 5 in length, 5, 4, 3, 2, 1 for simplicity's sake, and we are in the second pass, it means that that list will now be 3, 2, 1, 4, 5. The inner loop would read, for index in range from 0 to 5, take away 2, take away 1. 0 being is the beginning, 5 being the length. Take away 2, because we're in the second pass, take away 1 is to prevent that error. So in other words, the index would read, well, the for loop would read, for index in range 0 to 2. This means that the only elements we are concerned are the numbers 3, 2, and 1. Because 3 would be index 0, 2 would be index 1, 1 would be index 3. And these are the only numbers that are out of order. So now that the inner for loop is structured, you need to actually move the numbers up. So we get the first element located at index 0. We check it, is it greater than the one next to it? If it is, we swap. This bit of code is just how we swap elements in a list. Well, it doesn't have to be a list, but in this case, we're swapping a list, so that's what we're going with. So just a really quick example, say you have A and B with respective values 4 and 5. This operation technically makes 2 tuples. A and B is one tuple, 5 and 4 is the other tuple. It then reassigns A to 5, whilst also reassigning B to 4, so it swaps them. Similarly, when you have ARR or array with the common index, so array J, and you then have array J plus 1, which is the next position, and you equal it to array J plus 1, then comma array J, it's the exact same thing that's happening. You're getting a common position and you're assigning it to that next position, and you're also grabbing that next position whilst it's still that thing, and you're assigning it to your common position. So you're basically you're doing that at the same time, so there's no like mistakes or errors or anything like that. We get the common position, which is index 0, and assign it to index 1. Index 1 now becomes that common position. It then repeats. So we get the common position, which is index 0, and assign it to index 1. And then we get index 1, and we assign it to the common position, which is index 0, and that's a swap. This repeats. Is the common position index 1 bigger than index 2? If so, same thing happens and it swaps. If it reaches the end of the inner for loop, it sets the value to true, the swap value, and it goes to the outer for loop for another pass. When that outer for loop ends, the list has to be sorted by then. So what about this swapped value? Technically we don't need it, but it's to make things run faster, so we include it. It works by checking if we did any swaps during the last pass, because every pass involves one swap. If there's a pass that doesn't, it means that everything is sorted, so it breaks it out of the loop and returns the list. I'm just going to go through this code that I made and explain the entire thing. So I'm just going to quickly run you down the full working example we've been working on. There is this bit here. This is exactly the same, but without the swapped bit. All the swap bit does is it ensures you don't do the maximum time every single time. So with this one, you'd always run n-1, even though it's already sorted. With swapped, it stops that. And I will explain that in a bit. So it works with the first list. When we're working through it, n has the length of the array, so this will be 7. So it'll be 1, 2, 3, 4, 5, 6, 7. It's 7 items. Then for the outer loop, this is how many passes we're doing. For I in range of 6, that's what n-1 is. Swapped is false. It always gets set to false because you don't know if the next pass will be the final one, basically. And for the inner loop, this is where the actual swapping happens. So you start at 0. You don't have to write 0. I'm putting 0 in here so you can see more clearly what's happening. But what this is saying is we're starting at index 0 and we're going up to n, so 7. So let's just put 7. So you got 7. Then minus I. Right now, I would be set to 0 because we haven't done any passes yet. And minus 1. So what's happening is we're now doing 6. So we're going up to 0 to 6. And that's because we start at 0. So it'd be 0, 1, 2, 3, 4, 5, 6. If that 1 wasn't there, then when we would do the +1 here, it will cause an error because there literally is there's nothing there. 6 is the maximum. And all this I does is, during the next pass, it just pushes that back. And it ensures that we don't do the 1 after it, basically. So for the if statement, we get array j. J, I'm just going to call index. So we got the index of this list. Right now, it's set to 0. So we're talking about this number here, 64. Is 64 bigger than 34? I would explain this before. You know how the bubble sorting works. It swaps it. So it is bigger. So you get the index and you equal it to this, which is the next position. At the same time, you get that position and you equal it to what you just had. And you do it like this, so it effectively simultaneously moves the position in each other's places. So it swaps them and solely put swap as equal to true. If that swap wasn't there, then this statement would run, because what this is saying is if not true, because swapped is a boolean value. So if not true means if false. So if this is carried on, meaning if this if statement was executed, this will still be false. So it will say if not true, on other words, if false, break out of the for loop because it is sorted. And then you loop around, that's one pass. So now this is incremented by 1, so you just move it back because 90 is in its correct position. And you redo it, returning the list. And when you return it, it will be here. So I'm just going to make a new variable, and then you apply this function, and it returns it. So now sorted array is now the sorted list that we just did. And printing it out, you get this fancy list right here. Hopefully I explained it well. There we go, bubble sort fully explained. As always, if there's something that's a bit confusing, leave a comment, I'll leave a reply or make an entire video explaining it. Other than that, I recommend my video on the range function, seeing as we use it heavily here, but also have other full detailed guides on other functions, methods, as well as other projects. The fact that you watched this long really helps with the algorithm, but it would really boost the video if you dropped a like. Subscribe if you want more full guides, explanations for projects, functions, method, and so on. In this case, it's algorithms.